awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Assalamualaikum and hi everyone. Welcome back to my channel. Jika anda pertama kali hadir, selamat datang saya ucapkan. Tapi jika anda pernah hadir dan kembali semula, tahniah kerana rajin dan sudi kembali. Jadi dalam video kali ini, saya akan discuss set soalan yang kedua. Dan kita akan mulakan dengan 10 soalan pertama. So, apa tunggu lagi? Jom kita mula. Okay, so soalan pertama. So, determine the SI unit for mu if a stretched string forms a first harmonic where frequency F obey the following relation. Okay, so we want to determine mu. So, I will try to rearrange this equation. So, saya akan dapat 2FL is equal to square root T over mu. Okay, so always remember that T is the tension. Okay, tension adalah sejenis force. Kan? Tension adalah force lah. Okay, so sekarang kita rearrange that equation. We take the squared for the both side in order to cancel the square root. So 4F squared L squared is equal to T over mu. So mu is equal to T over 4F squared L squared. Okay, and T is tension. So since we want to determine the unit, so unit tension apa dia? Okay, kita selalu tahu unit tension adalah Newton. Okay, kalau saya terus saja buat, tulis terus unit sebab kita nak cepat jawab soalan objektif. So tension unit dia adalah sejenis force. F is equal to MA and the unit for mass is kg, where the unit for acceleration is meter per second squared. Okay, so you can write kg meter per second squared over, okay, so here we have frequency squared and L squared. Frequency, okay, kalau tadi kita tengok F, so the unit for frequency, so equation F is equal to 1 over T, where T is the period. So frequency selain daripada unit hertz, unit frequency awak boleh tulis sebagai per second. Okay, so sekarang saya akan tulis dekat sini lah, frequency kita adalah per second and frequency squared. Okay, refer daripada sini lah, substitute all the units sebab kita nak cari unit sekarang ni. And then L squared, the unit for L is meter, so saya akan letak meter squared. Okay, so apa yang kita boleh cancel? Okay, M kita boleh cancel, okay, 1 and S negative 1 squared. Okay, kita boleh cancel dengan S negative 2. Okay, boleh. Okay, so finally the unit for mu, you akan dapat kg, okay, per m, or you can write as kg per meter. Okay, so the answer is D. Okay, good. And then next question, which is question number 2. Okay, so we have an object initially at rest, so u is equal to 0 meter per second. Okay, and it's moving in positive x direction, which is to the right, at uniform acceleration A is 2 meter per second squared until it reach a velocity of 4. Okay, kita keluarkan semua maklumat dia bagi. Okay, and then what happened to the object? The object then travel at a constant velocity for the next 2 seconds. Okay, so kalau saya akan lukis timeline dia. Saya namakan ini point A, and then the object will move until point B. Okay, selama mana dia bergerak, sejauh mana dia bergerak, saya tak tahu. Okay, so yang saya tahu adalah at point A, so it start from rest, okay, and at B, it reach 4 meter per second. Okay, and we already know that the acceleration from A to B, okay, from point A to B is 2 meter per second squared. And then soalan kata apa? The object travel at constant velocity sampai dekat point C. Kalau constant velocity, velocity at point C mestilah sama dengan B tadi kan? 4 meter per second. Okay, and then dia kata dia bergerak from B to C, okay, dalam masa berapa? In 2 seconds. Okay, finally the object decelerated uniformly at 2 meter per second squared until it stop. Dia teruskan perjalanan daripada C sampai point D, and then dekat point D the object stop. Okay, and deceleration of the object A is equal to negative 2 meter per second squared. Okay, so itu saja maklumat yang kita ada. Okay, so soalan minta kita kira calculate the total time for the whole journey. So total time for the whole journey means that start from A to point D. Okay, so yang kita dah tahu masa yang diambil B ke C adalah 2 seconds. So tak ada masalah lah. Sekarang kita nak tengok berapa masa yang diambil untuk ini dan untuk ini. Okay, so we start with A to B first. So saya letak AB. Okay, so kita dah ada V, kita dah ada U, kita ada A. Then we can straightly find T, where V is equal to U plus AT. Okay, V 4, U is 0 plus A 2 T. Therefore, time taken to travel from A to B is equal to 2 seconds. Okay, so kita dah dapat masa yang ini. Okay. Okay, and then next, okay, we want to calculate what is the time taken for C to D. Okay, so kita ada VD, sama juga macam tadi lah. So we can find VD is equal to UC, because it start from C, plus AT. So kosong, okay, VD kosong, UC is 4, and A is a deceleration negative 2T. Alright, therefore T is equal to, this one is TCD is another 2 seconds. Okay, so kita dah selesai. Okay, and then the total time taken from A to B, T total should be equal to, okay, TAB plus TBC, plus TCD. Okay, and it is equal to 6 seconds. Okay, so the answer is B. Alright, so let's proceed to the next question. Question number 3. Okay, so now Ajoy just released a stone from the top of a building. So let's say this is a building. Alright, so this is the stone where the height of the building is given 10 meter. Okay, where the height of the building is given 10 meter. Okay, and then what is the speed of the stone at 2 meter from the ground? So we want to calculate what is the speed. Okay, so it's moving downward at this point, which is 2 meter from the ground. Maknanya bola itu dah travel ke bawah ini. Okay, sejauh 8 meter. Kalau 2 meter from the ground, that's mean the ball travel from the top of the building, okay, to that point is 8 meter. Tetapi jangan lupa, the motion is moving downward. So SY daripada top of the building tadi, okay, sampai dekat point yang 2 meter from the ground, mesti letak negatif 8 meter. Okay, so negatif tu jangan tertinggal. Jadi apa kita nak kira? What is the speed? We want to find Vy. Okay, because the direction is downward, so we want to determine what is the Vy at that point. So we can use equation Vy squared is equal to Uy squared minus 2G/Sy. Okay, bagaimana pula untuk maklumat Uy? Baca soalan, dia sebut release a stone. Bila perkataan release bukan throw, so maknanya the release, kita just lepaskan saja. We consider Uy at that point is equal to 0 meter per second. Okay, so this is 0. So we want to find Vy. So Vy squared is equal to negative 2. 9.81 Sy tadi adalah negative 8. Bukan negative 10. Okay, so kita boleh tulislah Vy is equal to, bila kita ada square dekat sini, sebenarnya dia ada direction lah, plus minus. Dia ada jawapan plus minus 12.53 meter per second. Okay, kalau soalan tanya velocity, maknanya dia ada direction. Okay, so negatif jawapannya, negatif 12.53 meter per second. Tapi untuk soalan ini dia minta apa? Speed. So we just want the magnitude. Okay. So maknanya therefore, okay, kalau speed is equal to 12.53 meter per second. Ingat ya. Jadi kalau you ada soalan minta velocity and dalam pilihan jawapan ada positif and negatif. So kalau untuk soalan ni kita pilih jawapan kita negatif lah. Tapi sebab soalan minta speed, so kita hanya pilih jawapan ini. Ini yang paling tepat. Okay. Dan itu je yang ada 12.53 meter per second. Okay. So finish question number 3. So let's proceed to the next question. Question number 4. So kita ada an army jet is moving with a constant speed. So U is given. Okay, horizontally. Okay, horizontally means that the motion. Okay, pergerakan jet tersebut. Ni jet dia lah. Okay, so it's moving in this direction. Kita ada UX is equal to 150 meter per second. Projected horizontally, moving horizontally means that nilai U hanya ada X sahaja. And how about UI? UI akan jadi kosong. Okay? And then it just drops a bomb and it lands forward on the ground at 750 meter. Okay, so maknanya dia ada bom dekat sini. Contohlah bom. So bila apa-apalah burung ke lepaskan batu, siapa saja that moving horizontally and then release an object. Okay, so we consider that UX for the objects is sama lah 150. Sebab dia dari kapal tersebut. Okay, dia daripada jet tersebut. And then, okay, the object will land here at this point. Kat sini kita pula boleh kira apa? V, dan kita sebenarnya boleh kira Vx dan juga Vy lah. Di mana? Jangan sesekali lupa, okay, for projectile motion, Vx at any point, kat sini ke, okay, so Vx dia mesti sama dengan Ux. Okay, Vx always equal to Ux. Okay, ni kita recall balik. Jangan lupalah konsep ini. Okay, and then soalan kata apa tadi? Dia jatuh lands forward on the ground at 750 meter. Okay, so means that this is the position kat mana kita release tadi. So daripada sini ke sini adalah 700, which is Sx. Okay, and finally soalan minta kita kira the height of the jet. Okay, so what is H? Ini yang kita nak kira. Okay, H ataupun SY. Okay, iaitu vertical displacement. Maknanya bom tu jatuh daripada atas sampai dia cecah tanah. Berapa dia punya vertical displacement SY? Okay, so we can write SY equal to UYT minus half GT squared. Okay, UI kita dah tahu is equal to 0. So we can cancel out this one. Dan ini adalah H yang kita nak cari. Okay, so dia akan jadi negative half GT squared. Tapi kita tak boleh selesaikan sebab kita tak ada masa, time taken for the bomb to lands on the ground. Okay, so kita boleh tinggalkan dahulu. This is our first equation. So we can proceed to the second part. Kalau tadi adalah vertical equation ataupun y component, so we can move to the next part which is Sx. Okay, sebab kita ada nilai Sx, kita ada nilai Ux and kita boleh cari T. Okay, so T is equal to Sx over Ux, which is 750 over 150. Therefore T is equal to 5 seconds. Okay, so maknanya bom tersebut mengambil masa 5 minit untuk mencecah tanah. Okay, untuk jatuh ke atas tanah. Therefore, now we can calculate height. Okay, H is equal to negative half GT squared, where G is 9.81 and T yang kita dah kira tadi adalah 5 seconds. Jangan tertinggal squared. GT squared. Okay, so H kita dapat adalah negative 122.63 meter. Okay, since the motion is downward, so kita akan dapat ini adalah negatif lah sebab pergerakan bom tadi daripada atas turun ke bawah. Okay, so kita akan dapat negatif. So the answer is C. Okay, Question number 5. A 1500 kg Peugeot car is traveling at 16.67 meter per second. Sorry. Okay, so we have M is equal to 1500 kg. And then we have U 16.67 meter per second. And accelerates to, maknanya kereta itu bergerak, okay, memecut sehingga V dia adalah 30.56 meter per second selama 2 minit. Okay, and please change to seconds, which is 120 seconds. So now we want to calculate the impulse of the car. Okay, so always remember equation. Impulse is equal to the change of momentum. Kita nampak dekat sini ada perubahan velocity. Okay, so bila ada perubahan velocity, kita akan boleh kira lah the change of momentum for the object. Boleh? Nah, selain itu, impulse juga kita boleh kira by using this equation. Okay, tapi kita tak guna yang inilah. Okay, kita guna yang ini. Okay, so masukkan saja dalam formula J is equal to MV minus MU. Okay, so finally we can substitute the values. 1000, kita faktoriskan dia punya mass. So V 30.56 minus 16.67. So J is equal to, the impulse is equal to 2.08 times 10 power of 4 Newton second. Okay, so the answer is B. Alright, next question number 6. Okay, so question number 6, we have a bowling ball move towards a stationary bowling pin. Okay, kita ada bowling ball. It's moving in this direction. Kita ada UB. Ini adalah bowling pin. Sorry, saya tak pandai lukis. Okay, so UP, bowling pin is at rest. Okay, thus your understanding of the principle of conservation of momentum by filling in the table 1 below. Okay. Okay, jadi kalau kita tengok kat sini, kita tak perlukan calculation kan. Kita boleh nampak saja. Okay, for number 1, bowling pin ni before collision, sebab dia adalah at rest, so it should be 0. Okay, so kalau yang ni salah lah. So C memang dah salah. Sekarang tinggal A, B dan D. Okay, and then for the total, so before collision, okay, so total kita kena totalkan lah bowling ball dengan bowling pin. So 50 plus 0, so this one should be 50, and 80 plus negative 30, this one should be 50. Okay, so mana yang tepat? Okay, yang paling tepat adalah B. Okay, so simple saja yang ni. Okay, next. Question 7. So this moving up at constant speed. So kalau kita tulis kita punya equation pun, so V is equal to, it's moving upward. Okay, kita tulis total Fy is equal to MA. So it's moving upward with constant velocity, constant speed. So A is equal to 0. So dia akan jadi N plus negative W equal to 0. So means that the normal force lah. Okay, which is equal to W, where W is equal to mg. Okay, sama. And question number 8. So this is from chapter 4. So here we have a 70 Newton block and 35 Newton block are connected by a string as shown in figure. If the pulley is light pulley and frictionless, the magnitude of the acceleration of 35 Newton block is. So actually we want to find A. Tak kisahlah kalau soalan tu tukar kan, dia tanya nak acceleration nak 70 Newton block ke ataupun 35 Newton block. A dia kedua-dua blok itu bergerak sama So A dia akan sama lah. Okay, so jom kita lukis dulu free body diagram. So let's say this is M1. Sekejap ya. So this is M1 and this is M2. Okay, so if we draw all the forces on M1, we have normal force, and then we're going to have the weight W1. Lepas tu kita akan ada tension. Okay, so kita consider this as frictionless surface sebab soalan tak bagi pun mu. Okay, dia tak bagi tahu pun ada coefficient of kinetic friction. And then for mass 2, kita ada weight W2 and then the tension is upward. Okay, So I want to find the acceleration. So let's say we start with mass 1. Okay, so sekarang kita tengoklah objek ni bergerak ke kanan untuk mass 1 tadi. So the only force that is same direction dengan acceleration adalah tension. Okay, so we can write for mass 1, total Fx is equal to apa dia? M1A, sebab dia bergerak kan, ada acceleration. Okay, and then the acceleration is not equal to 0, so kita kena tulis lah. So the only force, okay, that provide the horizontal forces for the system for mass 1 adalah T. Okay, so kita nak cari A, kita tak ada T, so kita tak boleh nak selesaikan soalan ini. Okay, we let this as equation number 1. And then we proceed to the second part, which is for the second mass. Okay, so mass 2, okay, is actually moving downward. Okay, so the direction of A is downward, the direction of W2 also downward. So W2 akan jadi positif, T yang akan jadi negatif. Boleh senang macam tu. Okay, so you can write the motion is in vertical motion, so total Fy2, okay, which is equal to M2A. So here we have W2 plus negative T equal to M2A. Okay, so from here we can write that this is M2A, okay, M2G, okay, minus T equal to M2A. Okay, so we can try to rearrange this equation. Okay, so kita boleh dapat apa tu? T is equal to M2G minus M2A. Okay, so this is our second equation. Boleh? Jadi kalau kita tengok kat sini, kita ada T sama kan? Okay, so untuk selesaikan A, sama ada kita nak substitute pun boleh, ataupun kita nak macam mana, substitute equation 1 into equation 2, ataupun kita nak tulis equation 1 equal to equation 2, mana-mana pun boleh. Okay, cumanya dekat sini kita, let's say lah kita nak selesaikan, okay, substitute equation 1 into equation 2. Okay, so kalau kita tengok kat sini, soalan bagi kita weight kan, dia tak bagi mass kan, kita tak ada M1 dan kita tak ada M2. Jadi nak tak nak, kita kena cari dulu berapa mass 1, berapa mass 2, berapa M1 dan M2. Okay, so kita kira dekat sini. So W1 is equal to M1G. So W1 dia dah bagi, so W1 70 Newton over 9.81. So M1 kita akan dapat 7.14 kg. Boleh? And then for M2, M2 W2 equal to M2G, sama juga. M2 kita boleh dapat 35. Okay, sebab W2 35 Newton. Okay, divide 9.81 and it is equal to 3.57 kg. So sekarang kita dah ada dah nilai, iaitu nilai M1 dan juga nilai M2. Okay, so let's calculate acceleration. Okay, kita substitute equation 1 ke dalam equation 2, kita akan dapat, sekejap ya, M1A equal to M2G minus M2A. We try to rearrange that equation, so kita akan dapat M1A plus M2A equal to M2G. Therefore, A is equal to M2G over M1 plus M2. Okay, so M2 kita dah ada, M1 kita dah ada, so we can solve this problem. M2G adalah weight untuk mass 2, 35 tadi. Okay, ini adalah W2. Okay, so M1 kita dah kira 7.14, M2 3.57. Finally, acceleration is equal to 3.27 meter per second squared. Okay, so the answer is B. Alright, so finish example number 8, and how about example number 9? So for example number 9, here we have a lorry of mass 800 kg. Alright, so M 850 kg. and start from rest. So U is 0, and then it's accelerates until V equal to 40 meter per second dalam masa 10 second. Calculate the average power of the lorry. Okay, so kita nak kira average power. Okay, so general equation for power is work over time. Okay, so this is general equation. Okay, tapi sekarang soalan tak ada bagi W kan? And by using work energy theorem, okay, so W ini, okay, we can write that, okay, W is equal to the change of kinetic energy delta K, where K final minus K initial. Okay, so kita boleh tulis lah, K final adalah half mv squared minus half mu squared over T. Okay, so we can substitute. Ataupun kita nak factorizekan dulu M pun boleh, tak ada masalah. Okay, therefore P average is equal to, sambung kat sini ya, is equal to half mass 80 150 kg, V is 40 squared minus 0 squared over time is 10 seconds. Finally, okay, you akan dapat jawapannya adalah 68,000 watt ataupun 68 kilowatt. Okay, so the answer is C. And then the last question, okay, for part 1. Okay, kita habiskan soalan ni, nanti kita akan sambung untuk part 2. So here we have a bullet is fired into a sandbag. The graph of the kinetic energy of the bullet, okay, E with the bullet penetration S. Okay, contoh you ada sandbag dekat sini. Okay, and then you have a bullet. Okay, it's moving in this direction. Okay, lepas tu apa yang berlaku? Okay, so dia akan, so V final dia akan bagi tahu kat situ, the retarding force acting on the bullet during its motion in the sandbag. Okay, the graph of kinetic energy, E with the bullet penetration S. Okay, so kita nak kira the retarding force acting on the bullet during its motion in the sandbag. So kita consider V final dia kat sini adalah kosong lah. Okay, so apa yang kita nak kira? Daripada graf kita nampak dekat sini S ini adalah graf yang berlaku. Graf ini merujuk kepada apa yang berlaku pada bullet itu bila dia masuk ke dalam sandbag. Okay, so maknanya ini adalah dia punya S. Inilah dia punya S yang 0.15 meter. Okay, so we can take out the information that S is equal to 0.15 meter. Boleh? And then kinetic energy initial, K initial, and here is K final equal to 0. Okay, so K initial equal to 480 joule. Okay, sebab dia bergerak kan, VI, kita ada initial speed, and then K final, bila dia stop, and it is equal to 0. Okay, so we want to determine the retarding force. Okay, so retarding force tu dia mestilah bergerak in opposite direction. Okay, retarding force F retarding, dia mestilah direction dia opposite direction. Okay, sebab dia nak berhentikan bullet tadi. Boleh. Okay, so sekarang kita ada the change of kinetic energy for the bullet, and by using the work energy theorem, we already know that W is equal to delta K. Dan kita nak relatekan, okay, the work done by the retarding force ni tadi in order to calculate berapa F retarding. Boleh ya? So formula yang kedua adalah formula work done by the retarding force, where F, okay, saya tulis dekat sini. Okay, retarding force times S. Okay, cos theta. So inilah dia punya equation. Okay, so kita boleh tulislah. Okay, since you can see here we have two equations of work, so I will write that, okay, delta K is actually equal to F. Okay, so the work done by the retarding force yang menyebabkan ada perubahan kinetic energy tadi. Okay, so darab dengan S, which is the displacement. Cos theta, theta is the angle between apa? Between F dengan S. Mestilah 180 degree. Kenapa? Sebab dia kan bergerak ke sini. Okay, saya lukis warna lain. Okay, ini. Warna apa nak pakai? Biru. Okay, direction of S in this direction. But the direction of retarding force is opposite direction. So, saya akan letak cos 180 degree. So, this is equal to -1. So, delta K, K final minus K initial is equal to F R S. Negatif lah. So, 0 minus 480 negatif FR kita nak cari and S adalah 0.15 meter. Okay, kat sini kita boleh dapat 0.15 meter. Therefore, okay, negatif ni boleh cancel out. Okay, we can calculate the retarding force FR is equal to, okay, bahagikan dulu. And the answer is 3,200 Newton, or it is equal to 3.2 kilonewton. Okay, so the answer is C. Okay, jadi untuk soalan nombor 10 ni kena faham lah. Okay, retarding force tadi melakukan kerja kan untuk berhentikan bullet tadi. So we have change of kinetic energy. So saya akan tulis W is equal to delta K. So based on equation of work energy theorem, okay, saya menggunakan formula satu lagi, iaitu work done by the retarding force, okay, untuk oppose the motion of the bullet dan untuk berhentikan dia. Okay, sebab itu kita dapat cos 180 degree kat sini. Kenapa? Sebab cos 180 degree merujuk kepada direction, angle, theta, angle antara Fs, dia bergerak ke sini, tetapi retarding force mesti opposite direction. So, angle antara F retarding and S must be 180 degree. So, kita akan dapat dekat sini adalah -1. Okay, jadi itu saja untuk video bahagian pertama bagi soalan set kedua. So, kita akan jumpa lagi dalam video seterusnya. Okay, so jumpa lagi. Assalamualaikum. Bye-bye.